Hello and welcome. I'm Christine PEREY, your chair for today's IEEE-hosted virtual meeting of the AR community. Thank you for joining us for today's session. You'll be getting up to speed on the mixed and augmented reality reference model, a conceptual framework and set of classifications that are under development in the ISO Joint Ad Hoc Group chartered for this purpose. Today's session is the first of our AR community virtual meetings hosted by the IEEE to offer everyone an opportunity to attend a meeting without traveling and to contribute to the future AR projects for open and interoperable augmented reality. This session came about after our most recent meeting of the community in Munich on September 12th and 13th, 2014. During that meeting, Marius Preda, an associate researcher at Institut Mines Télécom Sud Paris and the co-editor of this document, he shared with the people who were attending the status of the AR reference model, and we thought that it'd be valuable to share this same update with those who couldn't attend. I'll be beginning with some background on the origins of this project and the process behind this document before we turn it over to Marius. Marius will go through the architecture and viewpoints, and then we'll take a tour of the document. Chul Kang of SK Telecom will present about the AR Browser. Chul is a product manager and responsible for SK Telecom's AR activities. He'll introduce the software architecture developed in 2014 using the OGC ARML 2.0 specification. And he'll talk about how SK Telecom maps itself to the roles in the enterprise viewpoint. This way you'll see how the reference model is used in practice. Before I get started, I want to thank everyone for joining and putting themselves on mute. If you have any questions, you can use the chat feature of WebEx and provide those to Shana Ramondi. All right, so let's get started. Well, augmented reality today seems like it's being provided by many, many companies. I want to thank Marius for taking the time to prepare this slide with so many different exciting companies who have already gone commercial or are providing technologies for augmented reality. Many of these companies are also providing services, and we'd like to think that this is by no means exhaustive. There are probably twice as many, 3 times as many companies than those on this screen, and still it's very, very small in number by comparison to the many, many thousands of companies and millions of service providers involved in the web and the internet today. So we have a long way to go before augmented reality is as pervasive as the web. But we could say that the ground is laid, everything's ready. We have the physical world, many, many millions and trillions of objects in the physical world. There are tools for authoring and for developing AR experiences. And there are experienced developers who want to distribute them to audiences. So there are perhaps as many as 850, or by the end of this year, more than 850 million people who have devices that have cameras and enough computational components to have experiences for the user. But still, you have to have a specific use case. What is the problem you're trying to solve? What's the engagement you want to have with the user? And then you have to have the digital assets. And all of these things seem like they're in place, but it's not pervasive. So what's still missing? Well, many people don't yet have the necessary skills to use the tools, and the tools themselves are perhaps not as intuitive as they need to be. They may not also cover all of the use cases that need to be covered, and there aren't extensions. They're not extendable. They don't interoperate, but with other solutions that people may be using for communications and for engagement with customers or training or other use cases. So there's not interoperability between technology components, and the whole process of creating and using augmented reality is very manual, very intensive, and it requires training. We need systems that reduce the manual investment, and automate the delivery and the preparation and delivery of experiences. We also need to have augmented reality integrated into our workflow and the other tools that we use in our daily lives. So what is open and interoperable AR? It's a complete end-to-end system in which there is an architecture with modular components that could be swapped or removed and added depending on the needs and depending on what's the innovation of different companies or open source groups. These multiple vendors or sources can all contribute to the improvement of augmented reality without reviewing or changing the workflow and still delivering the experiences that users expect. I think this is very similar to what we saw a decade or two ago and called the distributed computing reference model that has given us what we know today in computing and communications. It's also very similar to what we have today in terms of interoperability and extendability automation in the web. It makes it such an easy platform for us all to use every day, all day. The open and interoperable AR begins with physical world objects, just like we have everywhere around us. But there also can be any use case, and the digital assets can be used to prepare experiences with any software and use many different new workflows or existing workflows. And the result of that is that the user doesn't have to be searching for just this one isolated application. They can use any software product that is compliant with standards and that's ready to deliver the AR experiences. Open and interoperable augmented reality will permit us to have more consistent and flexible content and more flexible uses of technologies in our processes, more integrated and easier to manage. So really the whole goal is to simplify not only for the developer and the technology provider all of the steps prior to delivering the experience, all the authoring, the publishing, the integration, but also to simplify for end users how they find experiences, how they share them, and how they use them or consume them through their work or their personal lives. So to get to this goal, we asked ourselves quite a long time ago, where should we start? And it seemed that one of the best things we could do is to begin with existing standards. This grassroots community started now almost 5 years ago to achieve this goal. This open and interoperable content and experiences. There's a web portal, and you can get to it by looking for arstandards.org. We have many archived mailing lists that are specific to our projects, but we also have a general discussion mailing list and announcements mailing list, and we conduct face-to-face meetings. As I said before, our most recent meeting was in Munich. So we also have achieved quite a lot in this period of time. We've fostered and helped promote this collaboration between MPEG, Kronos Group, Web3D Consortium, and even the Open Geospatial Consortium to address 3D compression and transmission, some open and interoperable systems for 3D compression and transmission. We also have worked with the publishers of AR browsers, and we developed an interoperability pilot and proof of concept. We developed an architecture that was then implemented and released in May of 2014. We've also on our portal have published landscapes to show where the standards are and what the SDOs, the Standards Development Organizations, do. We have a calendar of meetings that we maintain, the glossary of terms that are used in augmented reality. And we are going to tell you today about this mixed and augmented reality reference model that started some years ago as a concept. It was a concept that was introduced in 2011 because people were already familiar with this distributed computing reference model. If you're not already familiar with that, you might want to go and look it up. And there are other reference models in the world, one around geospatial data and geospatial systems, reference model published by the Open Geospatial Consortium. And we asked ourselves, well, why isn't there a reference model for augmented reality, and how could it benefit people? So this discussion began, and some of the work began in the AR community meetings. The goal is to have a conceptual framework that everybody shares and can use, that we have this common viewpoints and consistent vocabulary that's not just consistent, but it's clear to everyone, and it can be used in talking about augmented reality concepts. This is an abstract framework. It's not intended, and it doesn't include any implementation details, but it does give examples to try to map out these conceptual components, these frameworks, to real-world examples. So we started talking about this, I said, in 2011, and over the course of a year, it became clear that we needed to have a process that was much more well-defined than was possible using just what the grassroots community could do. And so the International Standards Organization, ISO, formed in the winter of 2012, and starting in 2013, a joint ad hoc group between the Subcommittee 24 Graphics Group and the Subcommittee 29 Working Group 11, MPEG. This joint ad hoc group took the responsibility, took over the materials that we'd already begun preparing in our sort of ad hoc fashion. And then in early 2013 and through the last 2 years, we've been giving feedback between the meetings of the joint ad hoc group. And that's the process is well-defined, and each time it's published as a draft, and there's open dialogue between members of the community and the document itself. It does have an ISO copyright, and that's a good thing. It makes it, it preserves the integrity of the document. It is royalty-free, means it doesn't contain any implementation-specific details, so there's no charge for its use. There's no one who has any intellectual property that is exposed, and it's available to the public. It will be available after publication as well, and there'll be no charge for access or for its use. These were very, very important goals that the community had, and all the standards organizations wanted it to be this way, and we were able to achieve that. So who are the target audiences for the reference model? There are 4. Technology providers need to talk with experienced developers, as well as, in some cases, the end users. So the technology providers and the experienced developers are 2 of the very important audiences. End users need to feel that there is enough variety and choices of experiences that they can reach. They'll be beneficiaries. And the standards development organizations are also involved and benefit. The top 2 audiences get improved communication, so they can talk about the components, they can talk about the data that they're sending, the interfaces that they're writing without a lot of confusion, or with less confusion. They can also use the enterprise viewpoint to develop business models and understand better who they're selling to and who they're buying from. End users benefit by having more experiences available to them, and they also have more different kinds of hardware and software that they can use. So these are some of the benefits for end users. The standards development organizations have, they can better understand how augmented reality is relevant for them. They can see the gaps in standards and then focus new work on the development of filling those gaps. So that's how I wanted to give you the background and share with you where we started and how this all came about. So now I'd like to turn this over to Marius Preda. Marius, you're going to be speaking about the architecture, the organization of the document itself. Will you please confirm that you have now the capability of sharing your screen?
Yes, I should be able to share the screen. Can you confirm that you can hear me?
Yeah, I hear you perfectly. Thank you.
Great. So, hello everybody. I'm very pleased to give you some insights about the mixed and augmented reality reference model. What is important currently is that the document is at the CD stage. For the ones that are not familiar with standard, CD means committed draft. It also means that the content is relatively mature. We can still bring modifications, but let's say that the main sections are already there. Another important information on this slide is that the document itself is available, freely available. You can have the link here. You will have the slides later, and you can take the link. So let's go in the structure of the document. The goal of my presentation today is to indicate with not so much details the content. So I will go section by section, just to give you a preview of the content. So currently there are 15 sections, and I will go one by one in the most relevant ones. So mainly the document starts with the definition of the domain and concepts. We are also providing a definition of mixed and reality and augmented reality as a combination of representations between physical objects and computer-mediated virtual ones. And then something very important is to define what we understand by the mixed and augmented reality. As you can see in the picture on the right side, we have the mixed reality continuum as already defined in the literature, and we are taking the freedom to define mixed and augmented reality as something that contains the mixing between physical and graphical computer-mediated objects. So therefore, in the entire continuum, we'll go from the physical reality without including the physical reality to the virtual reality without including the virtual reality. So, saying very quickly, as soon as we have a mixture, then we can call it mixed and augmented reality, which makes a lot of sense. Okay, section 5 is about something that Christine already mentioned, is the benefits of using the reference model. And we decided to include this section in the document to make it more clear to the reader how he or she can use the document. So we classified these sections in 3 parts, and we make the distinction between a MAR application or a service provider that he or she has in mind what it would like to have as a system, and then the reference model only guide the development, helping in naming components. Then at the upper level, we also can use the reference model to derive business models, especially that some of them should be invented, some of them are relatively clear, but there is a lot of changes that will happen. So this is why we defined the value chain, we defined the actors that may be in the field of MAR and their role in such a way that companies can identify current business models can slightly change their business model to include mixed and augmented reality, or clearly go for the new ones. And finally, very important for standard organizations, less important for the other actors, was to identify gaps in current standards that can be the subject of enriching the existing standards, even creating new ones. Section 6 is about the terminology. So we tried, with the help of the community, with the help of many people, to arrive to definitions that are clear and acceptable for the large majority of users. This is the section that usually takes very long time in creating it, because we even today realize that different people understand different things by using the same words. So we tried to be as representative as possible, in the sense that to represent the community understanding of the AR. However, probably this is the section that it took a very large debate, and it will continue to do so in the future, I suppose. However, the terminology that is now defined is relatively clear. Then one of the main contributions of this document is the introduction of the system architecture. It is illustrated in this figure, relatively easy to understand. You have on one side the physical world that is sensed and recognized, let's say. Then you have something that is called the scene, in the sense of stage, or that contains various elements indicating what kind of real signals are analyzed, what it happens when something arises from the real world, graphical elements, behavior of the application, and so on. Then we have something that is called the MAR simulation and rendering engines. They are grouped in this diagram, but later on you will see that they have particular functions. Then we have the user that is interacting with the system by the display and the user interface. And for sure, this system is not standalone, but it will be connected to external services, or even to some repositories from where the media assets are downloaded. So this is the overall scheme. It has the role to set the scene, but more is to be found when we dig in details. Therefore, we created several viewpoints by using this architecture. The first one is called Enterprise Viewpoint. And the role of this viewpoint is to name the actors that are in the chain. So in the document itself, you will have some abbreviations like AR, ATC, CC, RX. You will find all the definitions there, but mainly these are names of particular type of actors and particular type of industry. Like AR, AC is the augmented reality experience creator. You have content creator, you have content aggregators, and so on and so on. So all of them are defined and their role is clearly identified. We also specified some potential business models. We also mentioned what kind of business some of these actors should set up. And finally, we defined successful criteria, especially for the end users. That means the user that will consume the experience, but also the user, the professional user in general, that will create the experience. Then in the computational viewpoint, the second one, we try to go more in details in the components, and therefore we identified for each component what are the main functionalities at the component level. So in this viewpoint, typically we will talk about, let's say, the tracker and clearly specify what is the functionality of the tracker and how it should work internally. Then, in the informational viewpoint, by using the same architecture, we are identifying the data communication between components. Here, I would like to say that the data communication format is not specified in the reference model. It's not the role of the reference model to define the API or even the data format, but the type of the data is specified in the reference model. So typically, we give examples what kind of input data goes in the tracker without really specifying the interface. Why I'm saying so is that some other standards, technical standards, are specifying data formats and APIs. Then, by using these components, we define what is called the classification framework. I don't know how you can read this, if you read it correctly, but anyway, you have the slides available later on. The main idea here is that for each component to specify some dimensions. So we took all the components that were identified from pure sensor, the real-world capturer, recognizer, tracker, and so on. And for each of them, we defined what is called dimension. As an example, for pure sensor, we have two dimensions, which are the modality and the source type, in such a way that for each dimension, we are able to specify the possible values. I take again the example of the pure sensor. So for the modality, it can be visual, auditory, electromagnetic waves, haptic, temperature, and so on and so on. By using this classification framework, someone that proposes MAR system will be ready instantaneously to identify what exactly he or she is implementing. So you may say, I have a system that for which the recognizer is using an image patch and the execution is done locally. So immediately you can classify the MAR systems, MAR implementations. We went even more than that, providing some classes. Currently, we identified 7 classes, and mainly they are classes augmenting visual data, classes augmenting visual data by reconstructing the environment, class about the auditory, oral modality, and so on and so on. You should see this classification not as a mathematical classification in the sense that one service or application can belong to several classes. It's more a kind of tag that the application will have on top of it. I move forward to section 14. The others are less relevant, at least for this presentation, and you will find the text in the document itself. Here in section use case examples and their coverage by the MAR reference model, we try to identify existing implementations. So all these images corresponds to something that exists in the nature. And for each of them, we specified what kind of system it is, what kind of class, what are the components that they are used in which modality, and so on. So we tried to refer to the most known ones. So if by chance your application is part of it, we already thank you for accepting, probably without knowing, that you are referred in the reference model. And if for some reasons you don't want to be referred, which I may understand, but it will be hard to see the reason, please let me know and we will replace your application. Then we had another interesting section about how the current solutions and technologies are covered by the reference model. And here we are referring to proprietary solutions You may find some of them listed here, but also to standard solutions. And we try to create a bridge between these solutions and the reference model, showing how they are using indirectly, probably, but at least how they can map to the reference model. Okay, this is my presentation. Thank you very much for your attention. And now we will move to the presentation of the first example of how this reference model was used to create one AR browser. So I will move to some tool that will present you.
Thank you, Marius. Marius, can you hear me?
Yes, it's okay. I can hear you. You can start.
Thank you. Okay. Nice to meet you, everyone. My name is Chul. I work for SK Telecom in Korea. Actually, I'm a project manager, and I'm in charge of AR browser development. Here, I would like to show mapping between MAR reference model and SK Telecom's AR browser. Okay. Let's start with brief introduction about SK Telecom's AR browser. At first time, we thought that the AR is promising technology, and we want to provide various service using AR technologies. We had seek open and interoperable AR standard to make our own service. We reviewed several standards available at the late 2012. Finally, after reviewing, we choose ARML version 2.0. It's a candidate standard from OGC. So we developed our AR browser almost a year from early 2013. It's currently is most complete AR ML based. Sorry, it's the most complete AR ML based AR browser currently with various additional features like we have authoring and we had tags for audio and video support, and we also provide SDK for the standalone AR application development. We have authoring tool, as I mentioned. We developed our. We want to let end users create their own AR contents very easily. So we added not only web-based authoring tools but also device-based authoring tools. These tools let users create their own location-based or vision-based AR service very easily. Developer can create more dynamic and interactive AR services by writing the ARML code, and they can upload those kind of AR service into our platform. Those kind of services is automatically provided to the user through the AR browser. Let's move to the next one. This is the high-level architecture of SKT AR browser. Basically, it's running on top of Android operating system. Currently, we don't support iOS. The colored box in the center is our AR browser engine SDK. We developed our AR browser using this SDK. Usually, developers can create their own standalone AR application using the SDK, and by combining the AR, ML, and information about the target, their location or target images, and the content, various type of content. We support HTML5 images, 3D animations, or video and audio also. So the SDK itself is consisted of three main parts. One is the rendering part. It's colored purple. The components colored purple are rendering components, and the green components are related to the AR/ML handling. And the pink components are the location and vision-based tracking engines. Yeah, let's start. Let me start mapping between MAR reference model and SK AR Browser architecture. In the enterprise viewpoint, there are three classes. One is the class 1 is providers of authoring and publishing. The class 2 is MAR engine component providers. The class 3 is service providers. And we thought SK Telecom want to perform several roles in the AR service environment. So we are going to provide AR engine to our business partners and to the parties. It's mapped to the device middleware and component provider. We want to be that. And in the class 3, basically, needless to say, SK Telecom is telecom operator, and we want to provide service middleware, if necessary, to our third parties and the business partners. I don't think the SK Telecom can provide all the related technology or services to our customer or our partners. So we are going to collaborate with our business partners. So our business partners can do some kind of important roles. They are MAR service provider, and the other is content aggregators. And in addition to that, many roles can be opened to third parties or developers. Once we have standard, they can create authoring tools, or they can create AR experiences for various AR services. So they are all about the enterprise viewpoint. In the computation viewpoint, the main component is MAR execution engine. It's directly mapped to the our SDK. Is AR Browser engine SDK. It's the core module of the SK AR Browser. And the context analyzer containing tracker and recognizer, and they are mapped to the tracker manager, which controls the tracking engine and the location-based tracking engine too. The simulator in MAR reference model is the main control unit. The same role is performed by the AR manager in our SDK. It controls all the modules, all the components in our SDK. It controls the tracking engine, it controls the rendering, it controls the parsing of the AR/ML, and etc. The event mapper is mapped to the event handler in our SDK. Actually, the event handler is an event loop responsible for event dispatching. Events can come from internal modules such as tracker, or events can come from the user interactions. Is from various user interactions, touch or click kind of things. The spatial mapper is responsible for rendering between the virtual object to be displayed to the scene. So the object manager is mapped to the object manager and the AR renderer of our SDK. The object manager manages the object is extracted directly from the AR/ML DOM document object model. Some of the objects contained in the object manager is copied to the AR renderer with additional attributes for drawing into the actual AR scenes. So move to the next one. It's rendering. It's about renderer. Rendering is performed by the open source 3D game engine. The name of the game engine is Augur. Augur is the open source game engine, and we have some additional rendering modules along with Augur is related to the content. They are video and audio and HTML5. These kinds of content need to pre-processing before it transferred to the game engine. So, and next slide is about the information viewpoint. In the information viewpoint, the MAR reference model defines the data communications between the various components in the AR system. It defines input and output of the component. Each MAR component has mapped component in our SDK. They are the 2D NFT recognizer and NFT tracker, location-based tracker, and so on. I recognize that we do support almost the same input and output attribute defined in the MAR reference model in the information viewpoint. Next slide is about the classification framework. MAR reference model provides classification framework. Our AR browser doesn't cover all of the technical features defined in the classification framework. We do support some of the main features. You can see what we implemented here. So they are what we implemented in the regarding real-world capture, recognizer, and tracker, and space and event mapper. Move to next slide. It's almost same. You can see what we implemented. Implemented in simulator, renderer, and video display, etc. The MAR-RM classify the architecture of AR platform. They are called system class. SK AR Browser support local recognition and tracking. It means that all the recognition and tracking operations are performed on the device. It's related directly. It has direct relationship to the MAR Class B. We have authoring tools for MAR experience creation. In the left side of the diagram, its output is ARML. ARML is transferred to the MAR engine. Actually, it's our SDK of the AR browser. It's interpreted and executed by the AR browser. Next one is about the GPS-based AR system. Is MAR Class G. We have capability for location-based AR services. It's very similar to the previous chart. Content designer can create a location-based service using the authoring tools. Its output is ARML, and ARML is transferred to AR browser. Then AR browser execute the ARML service. Yeah, this is last slide. I think this, in my opinion, I think we have to have open and interoperable AR system for the explosion of AR content and service. I believe the MAR reference model is very useful for me, who are actually developing AR browser, and I think you can have a chance to think about your own AR application or AR browser. If you're developing AR browser, you can review your own implementation and your business models. And I think you can have the insight in the various viewpoints provided by the MAR reference model. Yeah. Finally, we had AR browser based on the ARML 2.0. I think I finished my presentation, and I give the turn to Marius. Marius will cover more detail about the MAR reference model. Thank you.
Thank you, Sang-Cha. That's great. Thank you very much for your presentation. And now we're going to be looking at, I think we're going to actually move to Marius. I will give the presenter tool back to Marius so that he can open the reference model draft, the committee draft document open, and show that to us while we take some questions. I think while Marius is preparing himself and sharing the application, I'd like to ask a few questions that have come up before. Marius, one of the slides that you showed is Figure 4. It's the high-level system architecture. And some of the concepts in that high-level system architecture are not familiar to people. And I think this it really, we need to increase people's familiarity. Can you explain the meaning of a MAR scene? What's included in a MAR scene?
Yes, sure. So, yeah, I tried to say some words during the presentation, but indeed we need more details on the MAR scene. The concept comes as a derivation of the scene graph. So mainly a scene graph is responsible with defining the elements that will be presented, defining the application behavior, define the events that will be triggered by specific conditions, defining how the user is interacting with the, mainly the graphical components or with the entire scene. This can come into flavors. Some applications will have the scene, the MAR scene built in, like typically the games. The games currently have the scene built in. Of course, it uses external resources that will be loaded from files or different sources. But at the end of the day, there will be a scene that is keeping the entire set of elements and their behavior, temporal behavior. Or there is a second flavor that the MAR scene is represented in a formalism, and you saw in the previous presentation the example of ARML. There are others, mainly there are two currently that are open standards at that level, ARML and RF, which is provided by MPEG, where the idea is the content is first designed by using any kind of authoring tools, formalized in a language, which is a markup language that will be loaded by an AR browser, by an application able to decode, interpret that language, and start the experience. So I think.
Okay, thank
you. That's
helpful.
I saw one question. Yeah, can you read me that question?
Well, the question was about the ARAF. It was about implementations that are using the reference model, and so you want to.
Yeah. So what you saw in the previous presentation was the usage of the reference model by a browser that is built on top of ARML, provided by OGC. But there are some other browsers, probably it will be presented in another meeting, that are built on top of RF, which is a technical specification provided by MPEG for the markup language of mixed and augmented reality. And to answer to the question, indeed, as any other MPEG standard, RF comes with reference software implementation. So typically people have access directly to the source code of the browser.
So I'm not sure exactly. Laurent's question followed about collaboration, but I think that collaboration between different contributors, I'm not sure exactly, but the answer is yes, there is reference software in some implementations. This reference model isn't conceptual, meaning that it isn't it doesn't describe the details. But could you, Marius, could you go to Figure 6, the computational viewpoint? In this particular figure, there's the tracker rendering system that's in a box, and then there is a green box that is labeled external services. Can there not also be architectures in which the tracking is external? Can you
Yes.
clarify the relationship between the items in the pink box and those that are outside the pink box?
Okay, so the components that are in the pink box are mandatory components of an AR system. It will be hard to imagine an AR system that doesn't have a sensor or doesn't have a tracker, even a recognizer. In the same time, we already know that AR systems will be connected to external services like a web service providing a particular kind of data or providing particular kind of service. You don't have to understand this figure as being exclusive, in the sense that the tracker or recognizer, even a simulator, sometimes even the renderer, can be implemented locally or can be implemented as an external service. But in both cases, they are mandatory. So here the distinction is the external service that are illustrated in the green box are external to the main AR system and not necessary that are executed on an external source. Yeah.
Okay.
I saw another question. Can you read it? Because I prefer to keep my...
Yes. What is the standardization timeline, and when will the standard be finalized? I think it would be good here to, yes, share with us what you know about the timeline, but also make it clear about the conformance parts, please.
Yes. Okay. So as I mentioned when I started the presentation, this document is a committee draft, which means that it is proposed to be voted by the national bodies. So for the ones that are not familiar with ISO standards, an ISO standard is balloted at the national level. Therefore, the information is circulating through the national standardization organizations. As an example, in France is AFNOR for the French auditory. So CD means that the specification is relatively mature, but we are still waiting feedbacks from the national bodies that will inform the relevant actors in each country, and changes are possible in the document. The timeline that we foresee right now is that we will have a 3 months balloting period. Then we will move to FCD, final committee draft, another 2 months for balloting, and then once this goes, we have the final standard. So more or less in half a year, this standard will be finished.
Okay. I think that's useful. You mentioned that there are some examples. Before we go to the question for Chul, I'd like to stay with you for just one more question, Marius. You said that there are some examples that are in the current edition, section 14. You know, these appear to be academic and projects that were developed a long time ago, before there were smartphones or many of today's tools. Why were these use cases or these examples chosen? I think it's even farther, the examples. There we go.
Yeah.
Why were these chosen? Could you explain the logic, and you know, would it be useful to show more modern use cases that are familiar to people today?
Yeah, one of the let's say selection criteria was to be references that are well known. So all of them are relatively well known, well referred by the literature. When you start to do something in AR, it's relatively hard to not be aware about this. many others exist. Is the reason, let's say, that we don't want to be exclusive. We only want to give examples. Probably they are old, but in the same time, nothing changed a lot. So in the same manner where that we have, let's say, a class V augmentation years ago, it will be similar, of course, with some other performances, but the conceptual basics are exactly the same. Nothing changed too much in the AR for years right now. The only thing that changes is the technology, make it more mobile, make it more accurate, more robust. But conceptually...
So you're saying conceptually, and that's what the real purpose of this document is to provide the common shared agreement on concepts.
Indeed.
Okay.
This is why we are not going in the technology description too much.
Good. Okay, so Damien had a question for Chul. Chul, if you can put yourself, he asked about the Ogre 3D rendering engine. Why was this selected and what interfaces? Could you explain if this can be replaced with another kind of rendering engine?
The reason why we choose Ogre 3D as our rendering engine is related to the licensing. We actually at the beginning, I don't want to have any dependencies on the other commercial software. We want to create our AR browser without any license dependencies. So we try to use the open source as much as possible. As in the same way, we choose the Ogre 3D rendering engine as our rendering engine. So the interface is Ogre engine is actually is not commercial engine, so it has it's limited in functionality, and if we try to replace replace the Ogre 3D engine with the other commercial engine like Unity or Unreal, I guess it takes about 2 or 3 months. There are several kinds of interfaces, but it's totally there's no compatibility with the commercial 3D game engine. For example, Unity is totally different game engine.
Okay, thank you for explaining that. Okay, we had one more question. Marius, I think this is for you. The question was, can we use other specifications such as 3D video in the MAR reference model? Can we use existing standards to build a solution?
Yes. Actually, this was one of the main design idea, to be able to reuse as maximum existing standards. And the difficulty to answer to this is to identify what these other standards are able to do. Let's say that for us was relatively easy to make these bridges with MPEG standards because we know very well what they are providing and what are the functionalities, what are the limitations, and so on. This was also done relatively well to map with X3D standards. So I don't have any doubts on the possible bridges between the reference model and MPEG family of standards or X3D family of standards. In some extent, we also made this for OGC standards because we had several meetings with OGC representatives, and there are also some bridges there, especially for the geolocation of objects. So yes, indeed, to answer to Gautier's question, there are bridges that are there. They are clearly identified in one of the sections, and they are implicit in the entire document.
Right. Okay. Thank you. I think the subject of compression is outside the scope of the reference model. How the assets are presented to the rendering engine or to the execution engine is, the compression is done prior to, and the decompression especially, is prior to entering into this conceptual framework. I think we've kind of run short on time. I don't see any other questions coming up. I hope that those of you who joined us will find this valuable and will have an opportunity to study the reference model more closely. Thank you for your time, gentlemen, Marius and Sangju. Please stay in touch. I'd also like to invite everyone to tune in for another virtual community meeting similar to this on Monday, October 29th. It will be later in the day. We will begin at 11 a.m. Eastern Time. Once again, the IEEE will host our meeting, and we'll be sharing during that session the status of the AR Discovery Project. That's another AR community activity. For more information on viewing that session, I invite you to join the AR community, to visit the AR community portal, and you can also join the mailing list. I want to thank again the IEEE for giving us the opportunity to bring you today's meeting and for archiving it so that those who couldn't attend today can watch it later. Have a great day, everyone.